Okay, now I'm going to talk to you about the most important thing in this entire class. Equilibrium of concurrent force systems. It's a fancy way of saying three equations. These three, right here. They are the most important equations in this entire class. And they're very simple. It simply says that if you break every single force into components, well, for it to be in equilibrium, which means it's not going to move or accelerate, all the y components have to add up to be 0. And if you break it all into components, and then you add up all the x components, those have got to be 0. And all the moments that are caused by these force components, well, those have to all add up to 0 as well. What it tells you is that if you have a point that's rotating around, and you got a force going down, you're going to have a force going up as well to block it and keep it from rotating. You have these forces going up and down too because it can't translate up or down either. We want to make sure that it stays in its position. So if you see one force by itself and there's nothing else opposing it, that force has got to be 0. You can figure that out immediately just because there's nothing to balance it out. All the forces have to be balanced. And if the force can't be balanced, then it's just 0. There actually isn't anything there even though you drew it. So these are all the equations we'll need for any concurrent force system that's in equilibrium. And for everything in our class, it's always going to be equilibrium. So please work hard at memorizing these and understanding how to use them. Because these simple sets of equations are going to how you're going to solve all these things. Now look, how many do you have? You have 3 equations, which means at max you can have 3 unknowns. There are other equations that can help you, like you can take one force component, F, and well, you can say, well, I can figure out the x component and the y component by breaking it down with your trig functions. There are other things like that. Also, weight might be one force that you're given, and obviously that has its own equation, which is mass times gravity. But these are the 3 big ones, so most of the time you're going to have 3 unknowns. This is also per free body diagram. So if you have 2 free body diagrams, you get these for each of them. And also, if you have 2 free body diagrams, you've probably split it apart, and you'll get 3 for the whole thing, just all of it together. Now, if you're not quite sure what I mean by that, don't worry. We're going to go through these together. We're going to have several example problems, which will help you really figure out what I mean by this. But first, let's go over 2 methods for solving these equations. Now, you probably already know what my favorite is, and it's not the force triangle. This one right here, you're going to be using the law of sines, the law of cosines to solve it. And it works. When you have 3 forces, it's a fantastic method. Because with a 3-force system, it comes into a nice perfect triangle. With a 4-force system, though, you might have, some sort of crazy pentagon, which is less fun. And then a 5 and a 6 and a 7, it gets crazier and crazier as you go. My personal favorite is to break everything up into components and to say, okay, well, each of my little forces is going to have an x component or a horizontal component and a vertical component. And using my trig, I can figure out what those are. And then in the end, I'll, do that for every single force. And I'll say, okay, well, I've got all these forces. I'm going to take all their components and add them together and see where I get. And they should all equal 0. So I have down plus up plus, up. And that should equal 0. And I've got over plus this way. And that should equal 0. I look at them separately. If you do that, it will work out. There's lots of math, but it's always simple math when you go down that path. So be very careful. Simple math down that path. Okay, so we'll stop here. You're like, but you haven't shown us how to do this. You're right. Just watch the example video. It's all based on things we've done before, though. You're just taking the forces, you're going to break them into components, and you use those equations from the previous slide back over there to figure out how to solve the equations. So check out the example videos now if you're having any trouble understanding this, and you can see me work through several examples with these kinds of problems. Thank you for listening, and I'll see you all soon. Bye-bye.